So this is a problem about interaction terms and whether one has an effect on the other. So let's suppose that a college coach's salaries are related to two factors: team gender and sport. The two genders are, of course, male and female. And suppose the three sports being studied are basketball, soccer, and then baseball, softball. And so this problem, we consider two questions. Does the possible team gender difference in coach's salary depend on the sport? So that's a question about interaction. And if the question is no, does mean salaries differ between genders, or do mean salaries differ between sports? So one of the reasons for going over this is for you to recognize when you have an interaction. So gender difference in coach's salary depend on sport. You could also say, does the possible sports difference in coach's salary depend on gender? So is there something about the sport and gender that's being interacted to determine the salary? So you kind of want to remember what it is we're trying to estimate. We're trying to estimate salaries, and what is it depending on? Gender and sport. So let's define the different variables. So the first one is that x1 will be 1 if the coach is for a male team. Now, it doesn't necessarily mean that the coach has to be a male. And 0 if the coach is for a female team. And so the team is more important than the gender of the coach itself. All right, so that's for the male-female part. Let's go ahead and take a look. Well, we have 3 categories for the 3 sports, so we only need 2 indicator variables. So I guess I'm going to let baseball and softball be my reference variable. So x2 is going to be 1 if the coach is for basketball. What a great sport. And 0 if the coach is for another sport besides basketball. And then x3 will be 1 if the coach is for soccer, and 0 if the coach is for other. So in other words, if you are baseball, softball, you're going to be 0, 0, 0. All right, so let's go ahead and set up our model. So our model then is, because we want to provide for differences due to the sport and interaction between the two factors, you're going to have some multiplication. So since we have 1 here and 2 here, 1 times 2 means that we're going to have 2 interaction terms. If, say, for example, this one had 5 sports, and so we have 4 indicator variables, we would have, and say this one had 3, so we had 2 indicator variables, so 4 times 2 would be 8. So just kind of make a note of that. So the number of indicator variables for a particular category times the number of indicator variables for a particular category will be the number of interaction terms. So our model then will then be equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, but now we need the interaction terms, plus beta 4, interaction between males and basketball, x1 x2, and then we need 1 for interaction between males and soccer, and then plus an epsilon. So when we're talking about a model, this is our hypothesized model. That's why we use Greek letters and we add the epsilon. When we actually calculate our estimates, we would change these beta naughts, either beta naught hats or to b zeros. So let's go ahead and write a hypothesis in terms of that should be tested for question 1. So question 1 asks, does the team gender difference in coach's salary depend on the sport? Well, again, salary is my y, and then gender is x1, and the sport is x2, x3. So I want to look to see, is beta 4 equal to beta 5 equal to 0. So my option is at least one of these is not 0. So you could have beta 4 is not 0, or beta 5 is not 0, or you could have both. Another way you could write this is at least one of beta 4 or beta 5 is non-zero. One of the things of writing out the null hypothesis is that when you go back and reject or fail to reject, you can go back and see what you're actually rejecting or failing to reject. Sometimes I go through a whole problem and I get to the end and okay, I reject the null hypothesis. What does that mean? You can go back and look at the null hypothesis. So this is whether it's an interaction term. So if the data determined led you to not reject the null hypothesis, in other words, our interaction terms are not necessary, so we kept beta 4 and beta 5. What would be our model now? Well, beta 4 and beta 5 would both be 0. So beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon. That's our new model. So when we go to our new model to determine the main effect, we get rid of our interaction terms, and then we can say, okay, then we can determine whether there's a main model. So question 3 and 2, or sorry, we're looking at question 3. Do mean salaries differ between sports? Well, the sports are x2 and x3, and so the main effect then we're looking at here, our null hypothesis would be, well, beta 2 equals beta 3 equals 0. And the alternative is that beta 2 beta is not equal to 0, or beta 3 is not equal to 0, or both. Okay, and that's where we attest this, and this would be a partial F test. Let me just add a new one. A new question here is the difference let's say do mean salaries differ between gender? And this is where Title IX comes in. And so that one would be the null hypothesis would be that beta 1 is equal to 0, and the alternative would be that beta 1 is not 0. Okay, so it depends on your number of indicator variables to determine whether you have this main effect, or does it depend on this, or is there something happening with a particular category or factor and its level. Okay, so I hope that helps, and I hope you can get that correct if you're asked a similar problem on an exam.